Greetings! We are going to talk about debouncing a circuit or debouncing a button today. So one of the challenges we have with buttons is that they are mechanical pieces. And so you may have noticed when you're building circuits, when you have a button press, sometimes the button press doesn't register properly, or it seems like your code interprets one button press as 5 button presses, or there's just a little bit of variability that you don't expect. And this graph is essentially showing you what's happening. So as we can see here, that let's imagine you have the button as high, you press the button, it goes low. That's how you wired it. So what you're looking at here on this black line is actually the electrical signal. And so it goes from high and then it goes to low. But you can see in this gap, when you push the button until the state actually changes, there actually is a lot of fluctuation or noise. The noise comes from all kinds of places. Buttons are mechanical circuits, mechanical devices rather, and so there's a little bit of sticking when the circuit is pressed down. There can be noise, electrical noise in the system, and so this is what causes those glitchy button presses. So as we said, there's going to be some fluctuations as the buttons are pressed. This variation in what we expect and what's actually happening called bounce, meaning the signal is sort of bouncing a little bit in between high and low. And so if you think about what's happening, the argon's running very, very fast. It's running much faster than our button press. And so it's going to register that noise in multiple loops, most likely. So it's going to get button presses when you don't intend for button presses. So we have a way to solve it. And essentially it's writing an algorithm to be a very sophisticated way of dealing with button presses. The algorithm, it seems a little complicated. I'm going to walk us through it. The other advantage is that this is sort of an algorithm that you can always use when you have a button press. So we'll explain it, but recognize that it's sort of a standard algorithm that you find people using in microcontrollers, Arduino, Argon, things like that. It's a pretty common approach to deal with buttons. So it's something we can just use as we need to. So what we do is we're looking to see only when the signal has been stable for a certain amount of time. So you saw in that little window that the signal fluctuates for a short time, but presumably someone lifts their finger after the button press and then it suddenly works again. So what we need to do is only notice a signal change when it has been stable for a certain amount of time. If we do see a bounce, meaning we see a change from high to low or low to high, what we do is we sort of reset this counter that's using to say this is how long it's been stable for. So every time we see a bounce, we reset our counter. What we do is once we have a certain window where we say, okay, if the signal has been the same, high and high or low and low for a certain amount of time, then we can check to see if a button has been pressed. So in order to do this, I just want to explain one thing we're going to deal with, which is we have to think about the difference between the button reading, which is what is the current button showing right now, and what is the current button state. So state is we have confirmed that this is high and it should be high. Reading is maybe the state is still high, but the current reading is high and then low and then low and then high because it's alternating. So state is going to be we know this to be true. Reading is what's happening right now. And so we're going to have to make some logic that says, okay, this is a correct reading. Now we change the state. Or no, this is noise. Don't change the state. Okay, so here's our algorithm. If the current reading, meaning the value we just read, is not the same as the last button state. So that's going to tell you that essentially there's been some sort of fluctuation. We reset our counter, okay? Because if there's been a little bit of fluctuation, two things that could have happened. Either there's noise, in which case we do want to reset the button counter, or the button state actually did change. We'll still reset the counter, but if it's a legit change, it should stay stable. Then we check to see if the signal has been stable long enough. Now, long enough is a thing that we measure in these circuits. We usually say about 50 milliseconds is the time that the debounce should take. So if your signal from the last time you saw a bounce is greater than this 50 milliseconds, then we can presume that the signal is stable and we could actually investigate it. if the current button reading is different from the current state. Let's update it. What this means is, let's say that the signal was high, it's been stable for a certain amount of time, and now we see that it's actually low. Well, this counts as a legitimate button press. We should change the state of our program. And finally this block, it's going to be 2 ifs down. This is when we can execute any code that you want to happen on a legitimate button press. Okay, so you can see we added one if and then another set of nested ifs. All this kind of barrier logic will make our button presses more efficient. At the end of the code, you want to make sure you update your previous state so that you know what's going on. Okay, so I just want to look at a little bit of this algorithm broken down into actual C++ code. So we set up our global variables. We're going to have our previous reading. So this is going to be continually updated with what was the last thing that we read. And then the current button state is legitimately what is the verified state that we're entering. And then we do have a checking for the time there was a bounce, and then our delay. And that's typically 50 milliseconds. We could use something else, but that's a pretty common value. Okay, so now we're in our loop rather, we're trying to see when a button was pressed. So the first thing we do after checking the time and reading the button state is, if my current reading is different than my previous reading. So what this would mean is there was some kind of bounce. The signal changed a little bit. So let me update the last time I saw a bounce, because I know something fluctuated. I don't know how or why. Let me just update that. Then I say, okay, let's see what we got here. If the current time minus the last debounce time, meaning if I've exceeded the time that I think I need the signal to be stable for, cool. Well, then I know it's stable. So what do I want to do now? I want to see if the current reading is different than the current state, meaning I think I'm in the high state, the current reading is low. Well, if I've exceeded the threshold for delay, then I know it's legitimate. So I do actually want to update my current state to the new reading level. So I made a legitimate button press. And then in here, in this if statement right here, now you can put any code that you would have put before. That's what happens on a button press. Okay, so just adding in this extra barrier logic will keep the button working properly. And then finally, at the end of our code, we want to make sure that we add our updates. And here's the full code if you want to see it. Welcome.